Hey everybody, welcome back. Today we're going to start on our trigonometry. Okay, we're going to focus today on solely about tangent ratios. We're going to learn a couple other ratios, just the definitions, but today we're solely going to be looking at the tangent ratio. Okay, so we're going to be finding the tangent ratio of an acute angle. Now we are going to be looking at right angles, but we're going to focus on the acute angle because we all know that the other two angles of these on a right angle are going to be acute. Alright, the very first thing I want you to write down is a trigonometric ratio is a ratio of two sides of a right triangle. Again, use this on a right triangle. So pause now, write it down. Okay, I do want you to write this down. You're going to write it down once, and you're going to see it in your next two PowerPoints, but you won't have to write it down again. Okay, so write down sine, cosine, and tangent. Take a moment, write this stuff down. And write definition, symbols, and the diagram, please. Thank you. Okay, today I want us to focus solely on this tangent ratio. Okay, so that's all we're going to go through today. The tangent ratio of an angle is the ratio of the length of the leg opposite the angle to the length of the leg adjacent to the angle. So if you look at the tan A, okay, tan A, this is where your angle is going to go right after that tan meaning tangent. Okay, so you're going to say tan of A, which is this angle right here. Okay, you're going to look at opposite over adjacent. Okay, opposite leg over adjacent. So if we look at this angle of A, we're looking at the opposite angle, opposite leg, which is A. That's our opposite leg. Then we look at the leg that's adjacent to A, meaning it's next to A. Okay, so and that's going to be B. Now I do note that C is also adjacent, but that's known as our hypotenuse. We know that because that's the opposite leg of a right angle. So this is going to be known, if it's opposite the right angle, it's going to be the hypotenuse. If it's opposite of your angle, that's not a 90-degree angle, that's your opposite leg. And if it's next to your angle, that's going to be your adjacent leg. So when we look at the tangent of A, it's going to be A over B. Okay, opposite over adjacent. Okay, if we look at the answer of B, and I'll erase this here, okay, or the tangent of B, again, we look at the opposite leg, which is B, over the adjacent leg, which is this right here, over A. Alright, so start learning this stuff. There's a little anagram that we're going to talk about here in just a second that will also help you out. Okay, so on your calculator, what I want you to do is I want you to find that little tan symbol on your calculator. Hit tan, and then type in 65 and hit enter. Okay, when you come up with that answer, okay, it's going to come out as a decimal, and it's going to come out to be 2.144506921. If it did not come out to be 2.144506921, if it didn't come out to be that number, or 2.144, there's going to be something wrong with your calculator. Not wrong, it's just in the wrong mode. Make sure at the top of your calculator, if you have a scientific calculator, it's in the degree mode. It'll say DEG, not RAD. So it's in degrees, not radians. Okay, degrees, not radians. If it did not come out to be 2.144506921, then come back tomorrow and I'll look at your calculator just to be sure. So when we look at this, use your calculator to find the trigonometric ratio, which is about 2.144506921. Round to the nearest hundredth as it says there. So it's going to be the tangent of a 65-degree angle is going to be 2.14. Doing the same thing for 11 degrees. Again, you're pressing that tan button, hitting 11, equal sign, and you're going to get about 0.194380391. You don't have to write this down. I just want to make sure that you know what those digits are, what your calculator should show up. Okay, so when your calculator pops that up, 0.19 is your answer to the nearest hundredth. Again, if that does not come out to be 0.194380391, it is in the wrong mode. It needs to be in degrees, not radians. If you have a scientific calculator, it should be in DEG, not RAD. If you have a TI-83, TI-84, there shouldn't be a problem on it. It should always come out to be 2.144. Okay? So if you did not come out with these answers, bring your calculator into me so I can take a look at it tomorrow. Alright, again, just hit your tangent button and then your angle. Okay, this is what I want. This is a little anagram that helps us with our tangent ratios. Now, maybe you've heard this before. It's called SOHCAHTOA. Okay, so when you think of your trigonometry ratios, your trigonometric ratios, SOHCAHTOA. That helps us with sine, cosine, and tangent. SOHCAHTOA, meaning each of these, sine, that's what your S stands for, is equal to your opposite over your hypotenuse. Again, you're writing this down. Opposite over hypotenuse. This O stands for your opposite. This H stands for your hypotenuse. And it's going to be the exact same thing through the entire SOHCAHTOA. If you see an O, it stands for opposite. If you see an H, it stands for hypotenuse. Okay? SOHCAHTOA. Know that. If you know that, you have memorized the trigonometric ratio. Okay? Ka. Okay? C stands for, again, your cosine. Then you have A. That's going to be talking about your adjacent angle. Okay? Adjacent angle. And again, your H. So A stands for adjacent. H stands for hypotenuse. So it's going to be your adjacent over your hypotenuse. So when you're given a triangle, okay, here goes our right angle right there. We have A, B, and C. If I'm looking for the cosine, okay, and this is how you write cosine on your calculator. It's going to be cosine of angle A. We'll do this A, X, Y, Z. Okay, the cosine of angle A is going to be the adjacent over hypotenuse. So here's the adjacent angle side right there. So it would be Z, and your hypotenuse, which is the opposite of your right angle, would be X. Again, we're going to talk about sine and cosine tomorrow, but I want you to be aware of it right now. Today we're going to focus on tangent, which your T stands for your tangent. Your O stands for what? Opposite, yep. Over. And your A stands for what? Adjacent. So, if I look at the tangent of angle A, tangent of angle A would be Y over Z. Okay, we're going to get into a problem where we're going to use trigonometric ratios. A good way to figure out or why we do this, why we use trigonometry, okay, if you're trying to find, let's say, the height of a tree and you're given the angle of what you're looking at from the ground up and just one, either the shadow or the hypotenuse, you can figure out that height of the tree instead of finding a perfect proportion. You don't need a proportion in trigonometry. Okay, so write a trigonometric ratio as a fraction and as a decimal. I'll do the first one. I'd like to do the first one with you, and then I'm going to have you do the second one. So the very first thing we're going to do, okay, is we're going to look at tangent. Remember, what is tangent? That's our TOA. Okay, TOA, meaning it's equal to your opposite over your adjacent angle. Okay, TOA, opposite over adjacent. So now we're going to be looking at angle K. Okay, so now when we look at angle K, we're looking for the side that's opposite of angle K. All right? Opposite of angle K, that's going to be our 11. So our 11 is on the opposite side of where angle K is. So you're going to have 11 over and your adjacent side. What side is adjacent? That's not your hypotenuse. Okay? We know that 61 is our hypotenuse, but the other one going across, which is adjacent to K, is going to be 60. Okay? So it's 11 over 60. Again, opposite over adjacent. Here's your opposite angle in 11. Here's your adjacent angle in 60. And it all depends on which angle I'm looking for. I'm looking for angle K. It's 11 over 60. So, what is the tangent of angle K? So you take 11 divided by 60, and it's going to be 0.183 repeating. We want it to the nearest hundredth, so it's about 0.18. So find opposite over adjacent, and then plug in those numbers and divide. Try angle J, or tangent of J. Okay, very quickly, opposite over adjacent, which means when I look at, that is a J, not a G. Oh, unbelievable, Mr. Freeman. Okay, which means now when we're looking at this, okay, I'm focusing on angle J. Instead of angle K, I'm now focusing on angle J. So, angle J, I'm looking for the opposite angle of angle J. What is the opposite angle of angle J? Or sorry, opposite side. It's going to be 60 over adjacent is 11. Again, your adjacent is not your hypotenuse. It's just the one next to it. 60 over 11, you're going to get the decimal of 5.45 repeating. 5.45454545. Okay, so round it to the nearest hundredth, you get 5.45. Okay, about 5.45. Again, opposite over adjacent. Tangent. TOA. Opposite over adjacent. Okay, I'm going to do this one by myself. I want you to pay attention, see if you pick up on this, because you're going to do the same one. Now, there's a little different one, just same idea. Use a tangent ratio to find the value of x. Round to the nearest tenth. Okay, so if I look at this, I'm going to be using x. Notice this is not a special right triangle of 45, 45, 90 or a 30, 60, 90 triangle. So this one with 15 degrees, using this information, I will figure out what my x is. And that's where my tangent ratio comes in. Because what is my tangent ratio? Opposite over adjacent. So if I take the tangent of 15, we know that that's my opposite over my adjacent angle. So the tangent of 15 is equal to 10.2 over x. This is where I come up with an equation given the information that I know. Okay, I know I'm looking for the tangent of 15. I know the tangent of 15 is 10.2 over x. So now all I do is solve for x. However, I keep the tangent of 15 together. I don't write in the decimal. I want an exact answer. So keep tangent of 15 the way it is. I know in order for me to get x out from bottom, I need to multiply by x. Need to multiply both sides. Cross out there. I have x times the tangent of 15, which is equal to 10.2. Notice I kept the tangent of 15, didn't replace it with a decimal. I just left it as the tangent of 15. As I step through this, I know I need to divide by the tangent of 15. That's how I get that tangent of 15 away from x. Okay, because multiplication is happening here. So what I need to do cross out those. I'm left with x on my I'm left on x on my left side, and I have 10.2 over the tangent of 15. Now, we are going to find your decimal. Okay, so here on your calculator, if you take 10.2 and divide it by and hit tangent 15, and you're going to come up with a long decimal. It asks for rounding to the nearest tenth on this one. It's going to be 38.1, and our label is still in this. So it's 38.1 feet. So given an angle, given a leg measure of a triangle, I can figure out what x is. Alright? So x tangent of 15 is equal to my opposite over hypotenuse, 10.2 over x. Bring that x up to both sides, and you just need to solve. Exactly what you've been doing for a while, just using those skills and bringing it back into trigonometry. Alright, I want you to try this next one. Okay, so on this one, use the tangent ratio to find the value of x. Round to the nearest hundredth. Again, keep the tangent in there until the very end. Don't switch it to a decimal right away. Keep your tangent in there. Alright. Alright, let's see how you did. Okay, I know that I am going to be looking for my angle of 39. I'm going to be using that angle of 39. I'm going to be using my two sides here. Okay, x and 20. So now what do I need to do? Is I need to plug this into an equation. Find the equation first. Alright, I know if I take the tangent of 39, I am given, and the reason why I'm using the tangent is because I am given the opposite and the adjacent angle, opposite and adjacent side of angle 39. That's the only reason why I'm using tangent. I'm given the opposite and the adjacent. So because of that, I know that I can use the tangent ratio. So I have x over 20. Keep tangent of 39 in there. I need to take both sides, multiply both sides by 20. That's how we get rid of that 20 on bottom. They cross off. So I have 20. Again, keep that tangent of 39 in there, which equals x. So take 20 times tan of 15 or 39. Not 15, 39. Okay, so x is going to equal on this one, rounded to the nearest hundredth. I get my answer of 16.20. Okay, I do need that 0 in there because I'm looking for hundredths, and it's going to be meters. Now, this answer makes sense because if this angle is 39 degrees, the opposite angle would have to be what? Exactly. It would have to be 51 by our angle, by our triangle angle sum theorem. Okay, which means this side, the opposite of 51, has to be larger than the opposite of 39. And it is. So it makes sense that our answer is 16.2. Alright? We are done for today. We're starting to get into trigonometry. It's going to get a little confusing. I hope this video helped you out. If you have any questions, come in to me tomorrow. Have a good day.